Hello boys, hello gentlemen. I just wanted to do a quick video on how to do problem number 1. I may or may not do a video for number 2 on your stoichiometry practice problems. I understand that some people were struggling, so I decided I might just walk you through it. First things first, we need to balance the decomposition of silver sulfide into silver and sulfur. Most everyone got this. 8, 16, 1. So part 1A asks us, if you start with 15.3 grams of Ag2S, silver sulfide, how many moles of silver sulfide do you have? And I give you a hint, you will need to use the molar mass of silver sulfide. So what I recommend doing first, before anything, is to write down the given. So for 1A, the given is 15.3 grams of silver sulfide. And the hint tells us to use the molar mass of silver sulfide. In order to find that, we need to use our periodic tables. Remember, I have a collection of periodic tables in case you need an extra copy. But 1 silver is worth 107.9, I believe. And 1 sulfur is 32.07. But we have 2 silver, so we're going to multiply 1 by 2. And that should get us I'm going to round it to 247.9 grams per mole. So the molar mass of silver sulfide, 247.9 grams per mole, is the conversion factor that we will use to convert from mass of silver sulfide to moles of silver sulfide. So a conversion factor is always going to be a fraction. That's what dimensional analysis is about. So if we're given the mass, whatever's given to us first is the unit that's going to go on the denominator side. That's the bottom half of the fraction. So we're going to put in the 247.9 grams on the bottom, on the denominator side. And on the numerator side, we're going to write in 1 mole. 1 mole of silver sulfide. And what happens to the grams? They cancel out. And you're left with 15 divided by 247.9. And that gave me 0.0617 moles of silver sulfide. So that's the answer to part 1A. .0617 moles of silver sulfide. I'm going to erase this. And I wrote down the answer to 1A up here. But don't forget, I always expect you to show your work. Now we're going to go into part 1B. Use your answer from part A to determine how many moles of silver you can potentially make. Use the mole ratio from the balanced equation. So the mole ratio comes from our balanced chemical equation. 8 moles of silver sulfide react to form 16 moles of silver, monoatomic silver. So I'm going to copy down the answer from part 1A. .0617 moles of silver sulfide. And the mole ratio that we're going to include is dependent on the coefficients of the balanced chemical equation. Again, if we're given the moles of silver sulfide, that's the unit that's going to appear on the bottom half, on the denominator side. And what we're solving for, it goes on the numerator side. So at the bottom we have 8 moles silver sulfide. On the numerator side, we include the 16 moles of silver that I asked you to look for. And a lot of you notice that you can simplify this to 2 over 1. Absolutely, you can do that. For the sake of keeping the numbers consistent, I am going to keep these numbers. It is definitely easier if you just do times 2 over 1. But for now, I'm just going to keep these numbers here just to remind you of where they came from. This 8 mole of Ag2S came from this balanced chemical equation, 8 Ag2S. The 16 moles of silver came in from the product coefficient right here. Let's go ahead and multiply this out. I got 0.1234. Moles of silver. So the mole ratio comes from the balanced chemical equation. What you're solving for goes on the numerator. What you're trying to cancel out goes on the denominator. Always remember that rule, because you want to cancel them out. I'm going to keep 1b over here and go straight into 1c. Use your answer from part A to determine how many moles of S8 you can potentially make. Use the mole ratio from the balanced equation. Okay, so we're going to go back to the answer from part A, 0.0617 moles of Ag2S. And we need to use another mole ratio. This time, however, instead of using the mole ratio of silver sulfide to silver, we're going to use silver sulfide to sulfur. So we keep the same 8 moles of Ag2S on the denominator side. And on the numerator side, we keep the 1 mole of S8. Again, I got those numbers from the balanced chemical equation, the coefficients. 8 moles of Ag2S, 1 mole of S8. 0.0617 divided by 8, 0.0617 times 1. Identity property means the same thing. Divided by 8, that gives me 0.00771 moles of S8. So this is the answer to 1b. This is the answer to 1c. Moles of silver, moles of S8. Let's keep these numbers in mind. I'm going to pause the video once again. So I erased 1b and 1c, but I kept the answers over here. So we're going to continue into 1d. 1d. Use your answer from part B to determine what is the mass of silver you can potentially make. Hint, you will need to use the molar mass of silver. 1D, we need to go back to our answer from part 1B. We left off with 0.1234. moles of silver. And the hint tells us to use the molar mass of silver. This time it's monoatomic, so we don't have to worry about multiplying it, but just as a reminder, silver is worth 107.9 grams per mole. Now this time we're given the moles of silver and we need to convert to grams. So again, whatever we put in the denominator is what we're trying to cancel out. Whatever we put on the numerator side of the fraction is what we want to solve for. So we're solving for mass. So 107.9 grams per 1 mole. Point 1234 times 107.9. I got 13.3 grams of silver. Okay, so that's how much, that's the mass of silver we can potentially make from the original 15.3 grams of silver sulfide. That was the given from the very first problem. Now we're going to continue into 1E. 1E. Use your answer from part C to determine what is the mass of S8 you can potentially make. Hint, you will need to use the molar mass of S8. So our answer from 1C, 0.00771 mole of S8. It's the same process as the previous problem. So we need to use the molar mass of S8. One sulfur atom is worth 32.07 grams per mole times 8. That's going to equal to 256.56. Once again, what we're solving for goes on numerator. What we're trying to cancel out goes on the denominator. 256.56 grams over 1 mole. Let's solve that in again. 0.00771 times 256.56. I got around 1.98 grams of S8. Okay? And that completes part 1. That's the end of problem 1, parts A through E. Let me know if you have any questions on part 1. I may or may not do a video on part 2, depending on how well this one goes and if you guys understand me in this manner. Go back in the video if there's something that you missed or if there's something you might need to, if there's something you might want to go back and replay, practice a little more. So this is part 1. Let me know if you have any help. And again, I may or may not do part 2. I'll wait for your feedback based on how helpful this video is. Okay, so good job, gentlemen. Have a great evening, afternoon, whenever you're watching this, and best of luck with everything.